We continue with this problem. We're still on this problem. Number 2, describe the event x less than 4 in words. Remember, x is a random variable. It's just assigned to an outcome. And what's the outcome here? Well, you want to know how many cups of coffee a U.S. Adult drink per day on average, right? So x less than 4 means x less than 4. Let me highlight this. X less than 4. So that one right there. X less than 4 means a randomly selected person who is 18 and over and US citizen who drink less than 4, so less than 4 cups of coffee per day on average. Right. Now, what is the P of x less than 4? Well, if you have the little capital P in front of it, that means probability, right? So P of x less than 4 means the probability of a random selected person, 18 and older, US citizen, who drink less than 4 cups of coffee per day. Right? So everything the same. All you do is just add in the probability word. Right? So x, P of x less than 4. And I don't feel like rewriting the whole thing, so I'm gonna duplicate this. And I can make it. I can make it in red. So the probability a random selected person who drink less than 4 cups of coffee per day. So basically here it's just practice you what does each things means. Express the event have at least 1 cup of coffee on an average day in terms of x. So here is the reverse engineer. They in problem 2 they give you the math inequality and then they ask you to express it in English. Now they give you English and they want you to convert it back to math. So at least mean what? Greater or equal to, right? So at least mean greater or equal to. So someone, which is x, have at least greater or equal to 1 cup of coffee per day. So that's the first question. Now the second question is that what is the probability of this event? So the probability, remember the probability is all you do is add the capital P. So the probability of someone drink at least 1 coffee per day. Remember, this is discrete distribution. How do I know? Because you can count, right? You can count how many cups of coffee they drink per day. Okay. So I can represent this on by using tick mark on a number line. Maybe starting with 0. And then 1, and then 2, and then 3 cups, and then 4 or more. It says right, 4, 5, 6, 7. 4, 5. All right, so P of at least 1 means what? I mean, I want to know P of either they drink 1 cup of coffee per day, 2 cup, probability of drinking 2 cup of coffee per day, probability of drinking 3 cup of coffee per day, and 4 or more coffee per day, right? You can P of x equal 4 plus P of x equal 5, but you don't want to write that. So how do I know P of x equal 1? Yes, I do, right here. Right, so P of x equal 1 right here. It's 26%. The randomly selected person drink 1 cup of coffee per day. 2, 3, 4 or more. Right. So you add them all up. Let's see. So I have 0.26 plus 0.19 plus 0.08 plus 0.11 is add up to 0.64. Or you want to write 64%, that's fine too. So that is the example of discrete random variable. Let's jump to continuous probability. A continuous model assigns probability as area under the density curve. The area under the curve and between any range of value is the probability of an outcome in that range. What does that mean? Remember, in discrete random variable, we compute the probability as the tick mark, right? Remember, at least one. So at least one means what? That 1 or 2 or 3 or 4 and 5, 6, etc. Right? Here is no longer that. It's continuous. So you represent the probability as the area under the density curve. So instead of sigma, it's going to be a continuous area. So there are two distributions, like I said, two continuous distributions. One is uniform, denote uniform A comma B, and I'll tell you what's A and what's B later. And the normal distribution denote as normal mu comma sigma, where mu is mean, population mean, and the sigma is the population standard deviation. Whenever they denote in things in Greek letter, those are your parameter, meaning it's belong to population. If it Roman letter is those are sample. It belongs to the sample, right? So here, uniform distribution. Below is a model for the random variable x, which represent waiting time in minutes to be served at a deli. What is the appropriate distribution with corresponding parameter? So they want you to write the distribution. When they ask you what is the appropriate distribution, and you know this is uniform distribution, then you write like this: U A comma B. Well, you get a feeling what's A and what's B, right? So A, so here is A. That is your A, and that is your B. A is the least amount of time that a randomly selected person wait in the daily, and 20 minutes will be the longer time they wait. Right? So from A to B. So 10, comma 20. By the way, the x-axis is the wait time in minutes, and the y-axis is represented by the probability density function, PDF. And the PDF of the uniform distribution has this formula, 1 over B minus A, which is 1 over what? 20 minus 10, right? Which is 1 over 10. So that will be my height. So this right here, maybe I'll use, I'll use blue. That is 1 over 10. Okay. The 15 is in the middle. That's your average. Now you take 20 plus 10 divided by 2, that's 15 minutes. So that's average waiting time in the middle. What is the probability that a randomly selected customer waits at least 16 minutes? At least 16. So 16, I'll say 16 right there. I'll make the line. At least mean what? Anything beyond 16, right? So that area right there. Remember, area probability of a continuous random variable is the area under the curve, right? So I want to find the probability of someone waited at least 16 minutes. I want to find the area of that shaded area right there, right? You know how to calculate the area of a rectangle? Length times width. So P of x is greater or equal to 16. What is my length? My length is right there, 1 over 10. I know that's 1 over 10. But my width is this one, 20 minus 16, which is 4. Right, so 4. 1 over 10. Maybe I'll use blue just to denote length and width. So together, 0.4 or 40%. Whichever way you want to represent it. Right.